So welcome to our workshop. So today we will talk about large language model. You see in the title of slide vibe coding. I previously planned to do it also in one session, but afterwards I see that have seen that it takes quite a long and decide to split it into separate sessions. So today we will go through the basics of LLM, see a little bit how the model is trained, how to distill the model, also dive a bit deeper in the RAG and MCP stuff. And vibe coding stuff, I would plan as a separate session. So approximately the session will be 1 hour. Of course, you can interrupt me in any moment, or if you have a question. So don't wait long. If you have a question, you can put it into the chat or just ask with a voice. It's not a problem at all. Okay, let's go ahead. So plan for today is introduce basics, what is large language model is, how they build, on the base of what. Then we see what is the fine-tuning and distillation, model distillations, how it helps to optimize the models for some tasks. Afterwards, I explain Retrieval-Augmented Generation, so very difficult abbreviator. Normally people say RAG. And MCP is Model Context Protocol, how they integrate it, how it works together with the model. I also introduce a little bit what is the agent agents, so what is the difference between just LLM and Gen AI agents. Yeah, and basically this is the all agenda for today. Vibe coding stuff will be demonstrated on the next session. Let's start. Basically, what is the source of LLM? What is the necessary element? Of course, very important block for LLM is the data. So we need somehow to collect the data and process it and train our model. So let's assume that model now is black box. And what about data? How the large language model, basic large language model are trained on which kind of data. So first step, it's very easy. It's just crawling the internet. So there is a crawler like Google C4 or other kind of that physically getting the all kind of text is mostly text information for most of model, and they just build it together in as a collection of the documents. Most of cases is HTML documents, but it could be also other formats. The next step is language filtering. So normally models works with English. Of course, it can also process documents with other languages, but the number of languages are important and limited. The next step is kind of quality filtering. On this step, there are some heuristic, either the website or text trusted enough. Is it truth in this document, or website is not very reliable. So it's kind of heuristic with different gradation. For example, text with Wikipedia normally have very high, they review it by multiple people, normally contains verified information. Therefore, they have very high grade of trustability, and kind of sites that newly created and unreviewed and also not visited, they have low rate and could be filtered completely out. The next step is stripping. So we only interested in the pure text content not the HTML text. So this is the huge part of element is out. After this filtering, the same with for XML document and other formats. So we are interested only in pure text. Very important step is deduplication. For deduplication, normally use min hash algorithm. The idea of this algorithm is a kind of hashing code for the document, but not a normal hash function that will compare documents one-to-one, either they equal or not. It's a kind of vector of hash values calculated on sets. The idea of these hash values is that they show how similar is the document. So there's a kind of vector comparison, and we say that with 70% probability the documents are duplicated, and the 30% they are different, and we can make a decision, yes, we filter it out because we have already the similar document. Very also important step is impersonation. So removed any kind of personal information from the documents, like stylistic identities, phone numbers, emails, and so on. Was very surprising for me, but the whole internet, basically the whole data, text data in English, what the human accumulated for all years, it's just 44 terabytes of data. So we basically can write it on the single hardware drive. Yeah, that's the only text that we are working with. There is a very nice site is Hugging Face. I just show you. Need to switch my screen shortly. There's a fine web stuff. So if you visit this site, it shows how this process, crawling process, so basically the different assets of information collected is, and step by step how many data volumes. About tokens we will talk a little bit later. What kind of web data is collected, how the data is filtering with high quality or pure quality. Deduplication algorithms we describe it here. So basically all what I explained step by step is on this side. So if you're interested in that, you can see some details of that. But I'll switch to presentation back. Good, we have now this huge array of the data with the text. What is the next step? So how we still would like to somehow to train the model that will answer our question and make some decisions. The next step is tokenization. So the process of tokenization is splitting this text on the tokens. So tokens is not letters, not words. It's also to understand how the tokenization works. It's basically quite easy for the Informatica. The idea, the reason why we need to split this text on the token. Currently, we have quite long sequence of words and letters in this text array, and what we our goal is to reduce the whole length. And if you imagine a binary code with 1 and 0, yes, only two symbols which we use, but the length of the text is huge. If we replace this with hexadecimal numbers, we have more identifiers for every position, but the whole length of the whole text will be closer, will be shorter. Basically, tokenization is the same process. So the idea of tokens, we find kind of piece of text. Normally it's words, but sometimes word is multiple tokens. And replacing this part with identifier. So we have some numbers at the end, and these numbers don't have any meaning in just identifier, and they will be the same for the same sequences. So the kind of encoding in more, let's say, with more with larger number of symbols, the whole text. So in this case, the phrase tokenization is essential for LLM will have 1, 2, 3, 4, 5, 6, 7, 8, 9 tokens. But it's good. The tokenization algorithms could differ a bit one to another. But the idea that we really from these large sequences of characters have a smaller sequences with these IDs of the tokens. And of course, so token has an ID, and if we have token multiple time in our text, then we will have just the same ID multiple times. Yeah, so every token will have an ID and how it looks like. The ChatGPT use the first version of GPT-4 use about 100,000 tokens. Current models even have more, some billions of tokens. So interesting that the whole text. So we have our 44 terabyte of text, and if we work with tokenization, we end up with about 15 trillion token, and this is our data that we are working with. I also can play a little bit with tokenization. I also show another screen. There's a tokenizer, site tokenizer vessel application, and so you basically can add your message, any kind of and you see how the it's split to the tokens. So Timing has 3 tokens for some reason. It's split it a bit more. So Workshops is only single token. Is also great, and our symbols is also single token. So you can easily split and play with different algorithms with different kind of tokenization here on this side. Let's return to the presentation back. Okay, now we have our tokens. So instead the huge amount of text, we have huge amount of tokens, about 5 trillion. What we do the next? Well, the next we start to train the model. And to understand how the model is trained, we need to understand what is inside. So they open this black box and understand a little bit how it works. So the purpose of the training process to calculate probability of the next token. So it's very, very similar how you works with autocomplete on your mobile phone or in your favorite IDEA. So you have a part of word, and autocomplete suggests you some options what could be the next one. So basically, the LLMs works absolutely in the same way. Perhaps only the difference that there are a set of options with different probability, with a higher probability and the less probability. And basically, the whole training process of the model is to calculate this next token in the sequence with probability of the next token in the sequence, and during the training process to tune this probability. There is two parameters that makes it's very important for the models. The first is the maximum context, a kind of maximal number of the tokens that model take into account for prediction. So we say we analyze 10 tokens or 100 or 1,000 tokens to predict the next one. And sliding window is exactly this current length, what is our context and what we use for prediction. So the first one is maximum, and the second one is current window, what we are sliding. So how it works? We have beginning of the phrase, deep learning is very, and LLM should suggest the next token into the sequence. And you see, after the calculation, there is a powerful with about 33% innovative, complex, weak, limited. There are a number of options with different probability. Yeah? And with some simple algorithm, we end up with perhaps more probable words and feel powerful here. That's the way how the model works. The training process, what exactly we would like to achieve is a training process. We have some sets of the data, what are correct from our point of view. And we try to tune the model in such a way that our prediction will be correct. For example, in this case, I'm viewing single directional case was with a bit higher probability and post with a lower probability. Yeah, so the post will be not selected, but in our test set, in our training set, we have a post, and our task is to tune model in such a way that post will have a bit higher probability and will be selected. This is the process of training the model. And of course, it's not a sequential process. There is a batch mode and a lot of parallel threads working. So it's possible to parallelize it because it's very compute intensive task. And it makes sense to do it in parallel for different training data sets. What is inside the model? So how it looks like. So this black box with the LLM, with the model, is a kind of mathematical expression with two inputs. The first input is our tokens, what we have in context. So we have already some tokens, and we would like to predict the next one. It is our inputs. And the second input is a kind of weights or coefficients. It's a kind of buttons which we can tune. We can a little bit adjust the position, can turn it, and this coefficients is very important to make a correct prediction. So the model itself, the expression itself is not something very, very complicated. So you see inside this equation is the weights, all these coefficients, and with X is our tokens, our context tokens. So it's somehow calculated, combines the weight and the tokens together, and as the output, they predicts next token with some probabilities. That's basically how the model works. There's very nice representation of the model. Let's me again switch my screen. There's a very nice site to make visualization of different kind of models. There's a smaller one. So this is visual representation of equation and operation inside the model. So mostly the mathematical equation with matrix multiplication and vectors operation. And dependent of the size of the model, it could be very large and complex, or could be simple one. Let's return to my presentation. So this is basically how the training process works. So we have some input, our trainings data and set of tokens. I have a model with our wages inside and have some output as the next token. And here we calculate the error. Either the output token is the same as we expect or not. And this error is a parameter, is a less parameter in the model trainings, and we're striving to do it to reduce it to zero, that all our training sets are correct. And with if it's not correct, we tune a little bit the wages in the way that output probability is correct. So is a higher and will be selected. So this is a kind of process of training the model. Every string of this table has a one means the one update of the model wages, and loss is a kind of error. So as less this error, this better. Yeah, so the model is better. You see, this is a result of model work when loss is between 8 and 9. So it's basically not really readable, and there are some characters. So basically, it's not something which you can use. In case if loss is between 5 and 5, it's still not good quality text, but you see a little local correlation. You can recognize some phrases here where terminated, you may have teamed, throw in, and as soon as your loss is close to zero, you have a result like you have in ChatGPT. There are some parameters in LLMs. Some of them we already discussed. The very important parameter is, of course, number of these wages or coefficient. As larger, so as preciser is model. So, for example, ChatGPT released in the year 2019 has about 1.6 billion parameters. Llama 3 from the last year has about 405 billions parameters, billions wages. Also important how many tokens used in the train. So the GPT-2 was trained on the hundreds of billions of tokens, and Llama 3 15 trillions of tokens. And of course, context lengths, what I already showed, this number of sliding window, how many tokens we take into the context to predict the probability of the next one. So how the model works, basically predict every token at a time. So here we have only one token in the first token in the context, and we predict the next one. After that, we predict the third one, fourth, and so on. And then we build the phrase with the model in this way. So after the training process, we have already inference. Inference is already a process how the model works. So we don't train this anymore. We have a fixed parameters and we really make a prediction. How prediction works, we have a context with single token and some probability of others, and it's kind of sampling. So we it's a stochastic process. We select one of the token accordingly to this probability. We kind of throw the coin and see what will be the next one accordingly the probability model calculated. Therefore, sometimes it's stochastic process and it's not always guaranteed that we have the same result. In most of cases, we will have the same result or similar result, but it could be deviation because it's a stochastic nature. Yeah, we have some probability, but it's still possible to have some deviation. Also, there's a parameters for model, a kind of temperature. When is the temperature low, we only takes very probable options, and the higher temperature we have a bit larger range of the probabilities of the options for the next token. Which kind of model we have currently on the market? I have collected some of them, is not all. There is, of course, OpenAI, the ChatGPT models, Gemini from Google, Anthropic Cloud, Meta with Llama. There is some parameters, how it's, what is the prices, quality index, speed of these models. Another table shows also the models. It's a bit larger list. It's also Nova from Amazon. And company who develop is multimodal, means either it works only with text or also could works with the images or audio files and videos. Reasoning is a property of model. Either we can track why model makes such kind of decision or not, and how to access the model. Every model has a release, so the kind of products that have release cycles. So I will also show one of this is from ChatGPT. It's available on GitHub. Let me show it again on my window. This is a ChatGPT model, and is obligatory to have all this large equation, mathematical equation, mathematical expression documented in the code. Basically, its code calculates this equation, what I showed before. And equation is not very complicated, of course. It's optimized by AI experts to be expressive, to parallelize. So very important, of course, is parallelize is good because training and also inference works in parallel. And it's a very important attribute of the model to have this equation parallelized. But the main value of the model is not in the equation itself, but in this coefficients, in the weights, what I show, because they are trained, they are tuned to be used for the inference. And basically, it's kind of transformation, the whole 44 terabytes data and tokens in the other dimension with the weights. So this information is kind of encoded, all information that we have in text encoded to the weights, and model be able to answer our questions and generate text completions. Let me switch back to the presentation. Okay. So we have trained model now. The question how to make possible that the model answers our questions or has a kind of conversation. So what we see before, the model just autocomplete, so has a prediction of the next token. To have a conversational model, it's necessary to fulfill a post-training step. It's more easy as training of the base model. So we train model to have a kind of conversations. The human asks something and assistant answer. So for that, there is a special characters, special separators start in the start of the conversation, a separator between the question and answer, and base model trained additionally on this data, and after that, they become assistance model that can really provide a conversation with the humans. Is it any question? So basically, I explain more or less base model. Is any questions on this step? Is it clear? Okay, nice. Then let's go ahead. There is two approaches that used also very often is fine-tuning and distillation. The idea of fine-tuning that we have some kind of pre-trained model or base model, and they have some additional domain-specific data, domain-specific information, and we tune the model on this information on the basis of this information to fine-tuned models. It's kind of additional training on the data that only you have and you don't like to share it with the base model. And also you set priorities and quality of this information with a higher grade that the model really considers this information as verified and high quality information. Another process is distillation of large language model. The distillation process is a bit another one. The idea of distillation is instead of train of the data from the internet, the student model is trained using teacher model. So the teacher model gives the information about probability of the next tokens to the student model, and can also limit some set of data set of question what we only need to answer. And this the training process will be easier because teacher model will transfer not only single token, which will be expected, but they'll transfer the whole set with probability to the student model. Why the distillation is important? Just to reduce the size, make it cheaper, and improve the speed in inference speed. So the decision with the student model is smaller and also faster. Okay, let's talk now about GenAI agents. So you probably heard about agents a lot. And what is the difference between large language model, LLMs, and GenAI agents? GenAI agents are from very, very simple definition. For me, it's kind of microservices in the GenAI. So we select kind of subdomain or bounded context. Say we need to resolve some task. We need to build a chat, for example, or need to make a decision accordingly, some business case. And we pack all necessary components inside the agent. So we definitely will have LLM. LLM is important part of the agent flow. But additionally, could have some data storage to preserve the context, because you see that the LLMs, it's just mathematical equation and it's stateless. So it don't remember any previous conversation, any previous result. It just calculates the probability of next token. That's it. There's a idea of token to save some conversation context. You can also have some tools like external API or database that provides additional information for the model. Using RAG and MCP, I will explain how it works on the next slides. And also could have another models that for some certain kind of prompts, you can communicate with other model if it fit better. So they're all is a kind of encapsulation. This block has name agent, and it can fulfill some, could cover some business subdomain tasks. And also very important that agent also can have some cycles. It's not single workflow that always. So you send a prompt, and agent answer with some result. In some cases, agent can make as multiple iterations. There is name agent loop. So they don't find answer or good answer in the first iteration. Perhaps it will ask some additional information from the user or refer some additional external data, makes a second loop, and continue these loops until it finds some acceptable answer on the question, or said that I don't have a good answer. That's it. By the way, to have model saying that I don't know, it's also not so easy, because you also perhaps see it was really visible in the early versions of ChatGPT. If the ChatGPT don't find the answer, it try to generate some kind of answer that's not true, but looks like reasonable. Yeah? This is a result of this probability choice. So if the model don't know the exact answer, it's still trying to do the best that to find some next token, some token with a more or less higher probability. And to this name has a term model hallucination. So model kind of don't know exactly answer, but try to find something that seems to be correct from the model point of view. And this special process to reduce this hallucination, to say if you don't know, you don't find the answer with a high probability, please report it to the user. Don't try to find something that's not true. How the agents use the information from external sources. There are two approaches to this. The first is it's not request, it's retrieval-augmented generation, or RAG. What is the idea of RAG? So we have an end user which send a prompt. I have some agent with a business logic and LLM inside. Additionally to that, agents prepare some data normally it's in vector format. So vector format, it's similar with the mean hash algorithm. The data is converted to some vectors with coefficients. And very important feature of the vector representation, that similar data even is has a little bit different form, but similar from the semantic, will have a very similar representation in the vector store. Therefore, it's quite easy to find some semantic correlation between your question and the data. So this is basically a separate process. The data what you have in your domain specific data, or data that's not available in the public internet, your process using embed model. So embed model is exactly doing this task. So they get the text or images or video and convert it in the vector format. That the semantically similar information will have similar representation. and store is in the vector databases. There's a number of vector databases. For example, Postgres, the PG support the extension PG vector. You can install it as a Docker image, or you can use it in the distribution, official distribution of the Postgres, and you will have automatically vector store that could store and could search for the vector information. Of course, you need this embedded model still to convert the text into vector store, but store you can just a normal Postgres with this vector extension. What happens the next? Agent has a prompt from the user, and before communication with the model, it search for this prompt in the vector store. Could be PG vector or AWS Bedrock or S3, any kind of vector store what's supported, and has some search results. So it's either that it's finds some information correlates with the prompt or not. Yeah, it could be also the case that it finds nothing, then it could not help. But for some prompts, it finds your domain-specific information, and this additional information just will be provided as enhancing prompt to the model. Yeah, so you search something and add to the model prompt this information additionally. So model now will have your specific domain data correlates with the prompt to make a final decision. And then model send a response, the user has a response. So it works quite well, but the problem of that first, there is a lot of databases with different, a lot of vector store, and you need to support different kind of protocols and communication between the agent. And the second problem, the agent is more complicated in this case, because it need additionally to search into the vector store, provide this information to the LLMs, makes agent implementation more complex. The just explanation how the vector data, how the vector works. So there's input data, and it's embedded model converted into the form that it's basically it's a set of numbers, but the feature is it's semantically similar information has very similar coefficients, not one-to-one, but similar. Therefore, RAG is good for some cases, but it's not. It's quite complex to implement, quite complex to achieve. It's still used in a lot of cases, but there are a little bit better approach with the name Model Context Protocol. What is Model Context Protocol? It's a kind of ability for model itself to decide when and which kind of data it's need. It could be some external data, external database, external APIs, or it's even could be some operations. Yes, on the first picture, you see some data. It could be database, API, some queues, some analytic data, big data, and LLM decided itself accordingly some criteria, either it needs some additional data or not. And interesting that it's not only about read the data, LLM even could proactively call some APIs, could make some orders, could fix in the errors. Yeah, so there are basically any kind of active operations that the model could do with this with MCP. And of course, there's read and execute the action should do securely. Yeah, so of course, not everybody could has access to the every data, and especially not everybody could execute the actions reliably and in standard way. And the answer on this is MCP, so Model Context Protocol, provides such a possibility, such functionality for the models. So if you just imagine that LLM is a kind of brain, in the agent. The MCP provides additionally vision, so the model could decide that I need some additional information from external source, and also hence because model can start to call some APIs, really execute some actions proactively. How it works on the flow? I have again user and the LLM. I just choose Amazon Bedrock, but as a framework, but it could be any kind of framework and any kind of LLM. I have an agent in between, very similar as a for RAG. And on agent side, there is piece of software, is named MCP client. And on the other side, there is MCP server. You can basically consider it as a protocol like HTTP or FTP or gRPC. It's very, very, very similar understanding. On the first step, of course, MCP client has a kind of handshake. First, exchange the version, say I support this and that kind of versions with server. Server answers with list of the versions it supports, and they kind of agreed on some version of the MCP protocol. And on the step 0, server provide a kind of tool list to the client. Why this tool list is important? It's exactly the description, what kind of data and what kind of actions are available from the MCP server. I said, for example, I can provide you data of the flights, or I can reserve flights for you, or I can provide some, or I can order insurance for the flight, or I can cancel flight. This all actions and data sources are reported as a tool list to the MCP client. And when the customer, the user send a prompt, agent forward this prompt to the model. It additionally, in the special format, sends this tool list that the model knows, aha, now I have the prompt, I have some task from the user, but additionally, I have some tools that I can use. Yeah, so I can, if it's really necessary, then I can use this additional information of data sources, or I can make some actions with a tool. And after that, the model make a decision. Yes, in this case, I need some tools, and it send special structured response to the agent back and say, yes, it's not my final result, but I need to call to execute some tools with parameters. So the list of parameters is reported together with tool list, and concrete parameters, because the kind of variables. You say you declare a function with some set of parameters, and concrete values of the parameters are defined by models, by model. And it's reported with a structured response back to the agent, and agent be able to execute the tool. Say, please now execute this tool with this set of parameters reported from the model, and has some result. Either it's very simple result, if you execute the action, it's successful or not, or it's more complicated result. If you request some data, it returns data back. And on the next step, this response from the tool execution will be also reported to the model. And based on this information, model make a final response and either report it to the user, or model can say also that I'm missing some information, I will ask it additionally, or make some loops. So it could be not only single iteration, it's perhaps ask for the different tools the next time until its model decide, yes, now it's final response, and I will report it to the user. That's how MCP works. It's really cool things, because model has in the hands this set of the tools that could be everything basically that it could execute. And this communication between MCP client and MCP server is standardized. So there's a specification, there's a public specification, and there's a number of SDKs, Python SDK, JavaScript, Java, and some others that implement in this MCP specification. So you can just integrate into your application, or provide, if you have already public APIs, REST API, for example, it's quite easy using, for example, Spring Framework or Python SDK to expose it also as MCP server to be used from the agents. And a lot of company doing it now. Yeah, so you have some public APIs, and they expose additionally these public APIs as MCP server tool. The MCP protocol also specifies security, how the user should be authenticated and authorized, use the normal OAuth flow for that. So it's necessary to have some IDP compliant provider that asks for the user, for the credentials, issue the GVT token, and MCP server on the base of the GVT token decided either user allowed to execute some tools or not. And also there is a concept of discovery, MCP server discovery. The client can have a kind of server catalog, MCP server catalog, and can find some server which is more suitable for their current tasks. Also, there's some versions of the protocol. The first version was based on the HTTP server-side event, HTTP SSE, which have some state. And on the next step, MCP was redesigned to use HTTP streamable protocol that is also stateless and scaled better in the Kubernetes cluster, or you can easily run multiple instances of the server, the communication stateless between client and server. Why MCP is important? Because it's widely accepted standard. It provides this data and tools from the model in hands of the model, and it addresses security and reliability aspect. With MCP, I would like to show a small demo. Let me switch to another screen. I think it will be more clear with this demo, how the MCP works. So what I showed now is a desktop from Anthropic, from cloud, and they use Cloud Sonnet 4 model as LLM. And what I did additionally, I configure our MCP server we develop on the hackathon. In this MCP server provides some information about flights. The information is completely fake, so it's not connected to the real flight reservation system, or don't get the real flights, but it's very, very good for demonstrate how it works. So if I ask in the chat, please find flights from Munich to Vilnius. It's very important for me on the 1st of August 2025. And I ask this question to the model. Hopefully it will work. What happens now, the model recognizes that I asking about flights, and model has a number of tools. Yeah, so one of the tools reported from our MCP server is find flights. And model extracts some information, some parameters from my request, for example, date, original and destination. And based on this, it's find some flights. This is basically response of my MCP server. Yeah, this is a request of MCP server, the cloud desktop sent to MCP. And this is response from MCP server. Yeah, this is basically, it's just a JSON response with number of flights. And based on that, the model display prompt with a response. So I have my flights now here. And what I can do, I can say please reserve or book some flights like American Airlines. I don't think that American Airlines flying to the Vilnius, but it's just a fake data. Right. For me. What is now happens, the model recognize that I asking to book in some flight, but one parameter is a class, what I would like to fly. It's either economy or business class, and this information is missing. Yeah, it provides some information about the cost, and I then use economy class. So this is basically agent loop. So model is not able to give me a reservation from one try, and model needs additional information from me, and it asks, and I provide this for the model. Yeah, now model ask for the permission to, because it's financial operation, and call the tool book flight with parameter, with my parameter, with the class. So the class I specified here, and response is just booking is successful with confirmation number, and the model responds me with the confirmation number. And basically, you can integrate any kind of functionality in the MCP. So, for example, I have seen MCP server that fixing Kubernetes issue. Yeah, so really gives the model access to the API, and model based on the stack trace and hierarchy can automatically fix the Kubernetes cluster. Yeah, so there is a customer who provide SMS sending for the campaigns, also using the model, and the model decide, yes, this set of the customer are important. This set of customer is important to send campaign information. They just provide API for SMS sending or email sending and send this information to the customer. So basically, you can integrate anything, because this tooling and protocol is standardized. There is SDK for that. It's only what you need. You provide your API and you expose this API as MCP server. That's pretty cool, I think. Okay, let me return to the presentation. Summary. What is the LLMs? So it's LLMs are just mathematical equation, mathematical expressions that quite it's not very complex. So there is some dependent on the model, based on some metrics on vector operations, and the training process of the model is a process of adjusting these parameters, these weights. That's a part of equations. That's a mathematical expression to minimize the prediction error. And basically, the model inference is not other as a prediction of the next token with certain probabilities. So agent is LLM plus something that necessary to fulfill a task for concrete domain. It could be memory, some external tools, knowledge base, and agent can make some number of the loops to deliver the final answer. RAC and MCP, Retrieval-Augmented Generation, and Model Context Protocol approaches to provide an external data to the model for specific domain knowledge or some sensitive data that could not be used to train base model. And also MCP enables some action, some external calls from the model side. It's basically all from what I could like to present today. Do you have any questions?
Can the LLM create the LLM?
Yes, so I already show the case when how the distillation process works. You have a teacher model, the larger one, and you can, on the base of the teacher model, create a smaller student model by transferring this probability. So the idea of model distillation is to have more smaller focused model on some kind of answer. And yes, general answer is yes. The models, LLMs, used actively for trainings, for quality assurance of the results. So you can basically use answer for the prompt with one model and validate the quality to another model. There's a, you see this quality index is also verified, validated partly by humans, but partly automatically by agents by another model. So answer is yes, in the different forms, but yes, you can generate from one LLM to another LLM.
Yeah, but it will be some kind of clone of this or the original LLM.
It's not clone in this case, it's a distillation. It's they take some part of information from the parent LLM, but not all of them. It's not clone one-to-one in this sense. It will be smaller and focused.
Yeah, but it will use the same equations or some mathematical background for the generated.
Not necessarily. So you can these equations could be also simpler and smaller. What is they used? They use the information about the next tokens with probabilities. So normally by train you have sequence of the token, and you have answer from the model, and you say no, this is my correct token. This is the training process. But with the model, you can take over complete set of the next token with probabilities. Therefore, the distillation process is cheaper and faster as a normal training process. But the model, the student model, could be built completely by other expression, could have a smaller number of wages, so it could have absolutely different parameters.
Okay, thanks.
Any other questions? Yeah, Konstantin?
Yeah, Andrew, one question. If we are talking not about languages, if we are talking about some graphics, videos, whatever else, yeah, idea is the same. So there is a tokens and there is a kind of vectors, matrix, and all the same, yeah?
Yes. So just the process of tokenization, it's a bit different as a text. It's more complex. But the idea, yes, LLMs just predict with some probability the next token.
Mm-hmm. Yeah, thank you.
Andrei, I have a question. Is there any libraries of the models, already ready models? Not only languages, but any kind of other? Mm-hmm. Or how to create it from scratch?
Mm-hmm. Yeah, you normally in the most of cases you take some base model. So it could be, of course, there are some very, very, very cool and expensive one, like Claude or Gemini from Google. There is a bit cheaper, like Nova from AWS, but there is also open source models like Llama. You can just check out and run on your laptop. It's also possible. Of course, it all depends on how many, what is the length of context and how many wages you have. But of course, real big models, you need GPUs or some powerful processing to fulfill inference. But for smaller model, you can do it on your laptop. And there are frameworks, so I mostly works with LangChain and the Python libraries and the Spring AI to integrate the model and to use it in your application. So perhaps we can do also a small part of the next session is not only vibe coding, but I can also show how to implement a simple chat with Spring AI, for example.
Yeah, but you're talking it's related to the language models.
Yes.
If I need some behavior model.
What do you mean with behavior model?
I don't know, special model for AIM. Yeah. To increase complexity of login depend on the errors that user doing.
Complexity of login. So you need to control some policies. Yeah, either the password is complex enough or not.
No. So if, for example, users input password first wrong, then add additional step, check through SMS, if again wrong, I don't know, add call, whatever, reject again to some additional step and so on. So behavior model.
But do you need really stochastic model for that? Because what you said sounds deterministic. Yeah? So for model, you need some kind of case that you either use previous knowledge, like data from internet, or your specific domain knowledge to make a decision, to make a stochastic decision with some probability. In this case, model helps you really, so to find some suitable text or to reformat it, for example, in the nice form, or find some suitable tool or estimate some tools. If you have very deterministic set of steps, then I would say that you don't need any model at all.
Okay.
Yeah. Stepan?
You said that to identify the next token, you have to have the have some chain of previous tokens, and then how does the model identifies the first token, or it comes from the tokenization of the prompt somehow? How exactly does it happen?
Basically, for model to start to work, they need a prompt. So you need to say something to model. Yeah, so you need to ask the question. So without this question, of course, it makes no sense, because it could be everything. You need some context. Yeah.
So it means that this chain of tokens starts with the tokens coming from prompt, right?
Yeah, on the very first step, it's coming from your prompt, and if it have already some history of conversation and some steps done before, it also use this context as well as this sliding window of the tokens. So, for example, with ChatGPT, if you ask some sequential questions, the agent remembers these steps and use also this information to make a more precise answer.
Yeah, that makes sense. Thanks.
Andrei, you can just ask without raising the hand.
Yeah, right. Okay. You've just shown us how the model, the LLM, can interact with the external MCP server, but I couldn't quite understand how can it understand which server to refer to. So like you have to like define the context, the prompt or something to let this model understand which server to ask to like call to and what data it should use to make it work.
Let me perhaps show it. The server in this case are configured. Let me share the whole screen, because the whole screen. If I go to the settings in the cloud and see the extension, I configure the URL of my MCP server. It's placed in AWS, and I also specify the token for authenticated. So for this agent, I have dedicated MCP server. Of course, you can use a number of MCP server, but on the very, very first step, every MCP server reports this list of tools. Say, I can reserve a flight. I can provide information about flights. I can order some goods and so on. So this list of tools with parameters is reported to the agent and then reported to the model. And model just decided based on the prompt which tool and which parameters he would like to call. So the server, in this case, server is configured for the model, and how the model decide which kind of exactly which information needs. That's based on the tool list.
Okay, thank you.
And if you will see some new requests to your MCP server with your authorization token,
yeah, it's just
you know where it's coming from.
Yeah, sure. No, it's just for demonstration purpose, and you can generate. You can use it basically. It's not prohibited.
Andrei, have you tried deeply all the models you presented? Showed like Gemini, ChatGPT, Claude.
I mostly have experience with Claude, as well with Anthropic, and with AWS models with Nova. And for a lot of tasks, as a result, for example, I experimented with vibe coding quality. The result, it's not, hardly depends which kind of model you use. So it's a little bit better with modern models and with expensive models, but for a lot of tasks, you even can use a simple cheap model, but very, very important which kind of data you use. So what prompt you provide, which context, which additional external domain-specific information you provide the model. This is very, very important.
So you can choose just the one model that is good for like coding purpose, or maybe for some other purpose.
It depends, of course, on which kind of task you fulfill with the model. If it's vibe coding, yeah, it's more depend on the tool. So it's either is Cursor or QDeveloper or Juni or something. At least they use different models and they have different approaches, different trainings approaches. Yeah, for the also they specialized on some technology stacks. So one model generate better JavaScript in the front end. Another tool is more dedicated for the back end. So it really depends on your task. But I would say that quality is mostly depend on the data what you provide to the model, and less depend on which kind of model you use with which kind of parameters.
Mm-hmm. I mean, I tried Claude actually. Yeah, I found it the best for coding. Yes, I mean, from what I tried, like with ChatGPT, with Claude, with Gemini. But sometimes it gives you like more than you need actually. Like it spends a lot of tokens, and if you use it like via API,
it's expensive. Yeah,
it's like
that's exactly the point. Yeah, the Claude model is very nice. They're good. They're really good, but they're expensive. And for a lot of tasks, you can just get the cheaper model and achieve approximately the same result with less money. Yeah, this is the point.
Yeah, actually, I also found that like some people even run some simple models, like lightweight models, on their local PC just for like code suggestions, like just within one line, so nothing goes to some external services. Like,
and it works even in this context. Yeah. So to fulfill a lot of tasks, you don't need a expensive and highly trained model. Also, the model distillation, for example, AWS provide for the customer service to distill the model and make it smaller, easy, and dedicated for certain tasks, because it's really can be factor 10 cheaper than afterwards. Thanks a lot for participation and for a lot of interesting questions. And yeah, see you on the next session.